Yes?
Is the quiz going to be on Canvas?
Yes? So yeah, so during class on Thursday, you need to have a computer or at least your phone, because you need to get onto Canvas to take the quiz. All right, new section. Shortcuts. For finding them. Up until this point, the way we had to find the limit, if I had a function, so let's say I have a function f of x is equals to say 3x plus 10, and I want to find the limit as x approaches 2 for my function 3x plus 10. What if I want to find this right here? I'd have to do this. I would have to draw a number line. On that number line, identify my limit, 2. Go to the left side, 1, 1.5, 1.9, 1.99, 1.99. Plug all of those into a function, into a table of values. Then I gotta go to the other side, the right side, 3, 2.5, 2.1, 2.01, 2.001. And then look to see what's happening in the y values and hopefully see that they're squeezing to the same number. And if they're squeezing to the same number, then that would be my limit. Yes? There is a nice shortcut that removes the need to do any of this to get to my limit. The name of that shortcut is called direct substitution. So we don't have to do any of this for this example anyway. We use a process called direct substitution. And by its name, it simply means plug the value in.
Is this the same process that was on the website?
I think so. Your website, how much requires this. And so to answer this question right here, the limit LIM as x approaches 2 for 3x plus 10, I simply use direct substitution and plug in the value 2. 3 times 2 is 6. 6 plus 10 is 16. This limit will evaluate to 16. If I had to do what I was talking about, create a table of values, plug all those numbers in, the number that this graph will squeeze to is 16. Isn't that a lovely shortcut?
Yes.
Wasn't this mentioned before?
Two people are speaking, one person at a time, please. Go ahead. Kamari? I think Kamari.
Oh, yeah. Okay, so I think some person did this before in like the last class, and then you said that it always doesn't turn out right though.
Yes, that's exactly my next statement right here. Direct substitution in our class works about 90% of the time. There's a 10% of the time where this is not going to work. You're about to see an example of that in a second. Somebody else had a question?
I was saying, could you explain it, how, like, the science behind it, like how it works like that?
Well, the science behind it is because these functions are what we call continuous functions. So 3x plus 10 is a nice simple function. I think 10 is the y-intercept. The graph goes like this and like so. And because it's a nice simple function right here, if I was to plug in 2, see right here, this coordinate right here is 16. The graph will be walking towards 16 on each side. So it ends up being the same value.
Okay, thank you.
So let's try a few of these because of course this is fun. So example number 2. I want to find the limit of square root of x 5x plus 1, the limit as x approaches 3. So for this function right here, for this limit, again, I try direct substitution. So that simply means take the function and plug in 3. 5 times 3, I believe that's 15. Anyone knows what the square root of 16 is?
4.
So this limit will evaluate to 4. Questions there? Go ahead. Try this one for me, please. Put the answer in the box. I want the limit as x approaches -1, 5x plus 1 divided by 3x minus 2. Oh, I got 2 of them actually. And limit as x approaches 0 of x plus 2 and times x minus 5. We'll come out the answer, put them in the box. Again, if you're not sure, let me know. So for the first one, direct substitution, that's going to be 5 times -1 plus 1 divided by 3 times -1 minus 2. That's -5 plus 1 divided by -3 minus 2. I'm checking your signs, checking to see if you still love your signs. -5 plus 1 is -4, yes? -3 minus 2 is -5. And like I was saying, a negative number divided by a negative number is?
Positive.
Thank you. Thank you. Again, did that clear it up for you? Anybody have a question there?
No.
On the other hand, plug in 0 again by direct substitution, just plug in 0. So that's going to be 0 plus 2 times 3 times 0 minus 5. 0 plus 2 is 2. 3 times 0 is 0. 0 minus 5 is -5. So it's just 2 times -5, -10. Questions there? Comments? Queries? Concerns? Huh.
Is this going to be on the quiz as well?
Yes, it's going. Oh, yeah. You're going to get something that's easy on there, right? Like I said, depends on how far I get. I can be able to tell you what's going to be on the quiz. All right. So remember how I said 90% of the time this thing works out? Let me give you an example where things don't work out. At least they don't seem to work out. So I think this is example number 3. I want to find the limit as x approaches 5 of x squared minus 25 divided by x minus 5. You should always try direct substitution first. Because, hey, most of the time, 90% of the time, it works out, right? So that's going to be 5 squared minus 25 divided by 5 minus 5. And that is 25 minus 25 over 5 minus 5, which gives me 0 divided by 0. Is that an answer? Can I write, is that an answer? Is the answer 0 or is the answer 1? Can I do that right here?
Do you put no solution or does not exist?
We have a question, right? What's the answer? And this is when your direct substitution starts to break down. Whenever you do direct substitution and it results in 0 over 0, we say we have reached what we called indeterminate form. This means that we have not done enough to determine the answer. listen very carefully to the language. Is it saying there is no answer? Is it saying that the answer does not exist? Is it saying that we're guaranteed to have an answer? No, it's not saying any of that. It is simply saying we cannot tell what the answer is right now. I.e., I cannot determine the answer. I.e., indeterminate form.
So just a question. So what that would mean is if we were looking for a different form of x to find a limit of it, then we could possibly have an answer.
Well,
With
that's true. Yes, that's definitely true. For example, if I was taking the limit as x approaches 10, I would definitely get an answer for this problem right here. Okay, but again though, remember, I am taking the limit as x is approaching 5, correct? That does not mean
Yes.
there is no answer. There may be an answer. Whenever we get to indeterminate form, this is what we must do. Whenever we get to indeterminate form, what we must do is we must simplify the equation and then try, excuse me, direct substitution again. Indeterminate form means I have not done enough to get the answer. Well, what must I do to get the answer? Well, there's several things you can do to the answer. The main one for this class is to simplify and try again. There are actually like 15 different things you can do when you're in indeterminate form. But we ain't gonna go crazy just yet. So I rewrite the problem. I simplify. So the way I'm going to simplify this problem right here is, notice the top is x squared minus 25. Isn't this a difference of squares? Do you guys remember how to factor a difference of squares in college algebra? I keep mentioning that class.
No.
This factors into two branches right here. One of them plus, one of them minus. What's the square root of 25?
5.
5.
5, and you have your x, and you have your x right here. X plus 5, x minus 5. Difference in squares always factors this way. And so this problem, after I factor it, my question to you is, now that I have factored it, can I simplify it?
Yes.
You can cancel out.
You can cancel out minus 5.
Simplify it by canceling out the x plus 5. And so it becomes the limit as x approaches 5 of just x plus 5. And now try direct substitution again. So direct substitution, that means I have to plug in 5, right? That's going to be 5 plus 5. That gives me an answer of 10. So this limit is equal to 10.
Okay, so now I have another question.
Mm-hmm.
So would both form of answers be sufficient enough? So the 0, 0 for indeterminate form in 10, or will you only accept 10?
Only 10. Indeterminate form says what? It says you not finished the problem, literally.
Okay.
Right? You have not done enough to get the answer. So clearly you're not finished.
Right. Okay.
The key thing about indeterminate form is it is exactly what it says. The answer can still be does not exist. The answer can be 10. The answer can be negative 15. The answer can be a fraction. The answer can be anything. You just have not done enough to get to that answer. Questions there? I think we have time for one more. We have time for one more. We have time. All right. Example number 4, I think. I have f of x is equals to x squared minus 7x plus 12 divided by x squared minus 9. I want to have the limit LIM as x approaches 3 for my function. So I'm saying, oh, look, I know direct substitution, right? I'm going to plug 3 into the function. When I do my direct substitution, I get 3 squared minus 7 times 3 plus 12 divided by 3 squared minus 9. That is 9 minus 21 plus 12 over 9 minus 9. And that works out exactly to be 0 over 0. Again, a lot of students are tempted at this point to say the answer does not exist, the limit does not exist. You don't know that. It could be, but you don't know that yet. Any questions so far? And so what I need to do is I need to take this function and I gotta simplify this right here. I need two numbers that multiply to give me 12 and add to give me negative 7. 12, I believe the numbers are negative 4 and negative 3. They multiply, give me 12, and when I add them, I get negative 7. So the top factors into x minus 4 times x minus 3. Yes? And then the denominator factors is a difference of squares, so x plus 3 times x minus 3. Let me pause right there. Have I lost anybody?
No.
So does this simplify?
You can cancel out x minus 3.
And so the simplified function, and so now I can take my limit as x approaches 3. That's going to be 3 minus 4 divided by 3 plus 3. 3 minus 4 is negative 1. 3 plus 3 is 6. And so my answer is negative 1, 6. Two different problems. Both of them started out as 0 divided by 0. One of them is a positive answer, 10. The other one's a negative answer and a fraction, negative 1 over 6. Okay? So can you see why they call this indeterminate form?
Yes.
Because literally you have no idea what the answer is going to be. All right, I got one last thing I need to show you, but any questions before I step into the very last thing I need to show you? I got to go back to that same statement that I talked about earlier. Remember how I said 90% of the time direct substitution is going to be good enough? Well, simplifying is good enough most of the time, but there are a few times where even that's not good enough. Let's say I want to find the limit LIM as x approaches 2 for this function, absolute value of x minus 2 divided by x minus 2. I chose a nice simple answer because, we're running out of time. So in this problem right here, the first thing I should try is direct substitution, correct? By direct substitution, can you see that I'm going to get 0 divided by 0? Plugging 2 in the top is 0, plugging 2 in the denominator is 0. So then the whole thing is 0. So this is indeterminate. But unfortunately, I cannot simplify this expression. See, the x minus 2's cannot cancel out because of this absolute value right here. So if I cannot use direct substitution and I cannot simplify the expression, how am I supposed to get the answer? Well, the answer to my question is you have to go back to first principles. Remember how to find the limit? You draw a number line, you put the 2 in the middle, 1, 3, plug in 1.5, plug in 1.9, plug in 1.99, and plug in 2.5, 2.1, 2.01 into the equation and work them out and see what happens, right? Taking numbers on the left and numbers on the right of the function. Do you remember this? Remember, this will always work. And so sometimes, for some problems, the only way to get the answer is by doing them the hard way. So x and y, plug in 1, 1.5, 1.9. I chose this example because it works out very nicely. When you plug in all of these numbers, you get the exact same answer, -1. Isn't that interesting? And so since all of these came from the left, I can actually write this. The limit as x approaches 2. From the left for this function right here is equals to -1. Because every single time I'm getting closer and closer to -1. Okay? Yeah, I plugged these all in at home already later on. If I plugged in 3, 2.5, 2.1, 2.01 into this function, the answers I get are 1, 1, 1, and 1. And so down here, the limit as x approaches 2 from the right for my function is 1. So with all of that information, can somebody tell me what the answer is going to be? What's this limit going to be?
1.
I have someone saying 1. Anyone else wants to give me an answer, the same answer or a different answer?
I would say 1. -1.
-1. Anybody else wants to give me an answer, a different answer, the same answer? David chimes in at -1. Anybody else?
Does not exist.
Does not exist. Clayton chimes, and he smiles when he says it because he's not 100% sure.
0.
0. Anybody else? Anybody?
Doesn't exist.
Does
Yeah,
not
I agree
exist.
with Clayton.
Where is it? Where is it? Where is it? Right here. When a graph has a jump, when the limit from the left is different from the limit from the right, the limit does not exist. The limit as x approaches 2 for my function right here does not exist. Questions there? So I'm out of time, so I gotta squeeze. I have to hurry up right here. So I had one limit where it's indeterminate form, where the answer was 10. I have one limit where it's indeterminate form, where the answer was -1/6. And then I have one limit where it's indeterminate form, where the answer does not exist. Can you see that 0 divided by 0 can be anything?
Yes.
Which is the whole point of the exercise right here. And that is why you can, I was keep saying, because I see divided by 0, I cannot simply say the answer doesn't exist. There is more work that needs to be done before I can do that. And hence the name Indeterminate Form.